Hi, it's MP the tutor here, and today we are looking at plotting straight line graphs, and then we're also going to look at plotting or sketching quadratic graphs and how that links to simultaneous equations on graphs. So here we have an axis and some squared paper. Now it might be worth having some squared paper to do this or some graph paper to have a little go on this. So there's a couple of ways of being able to plot y equals x plus 3. But what I'm going to do is I'm going to go down the route of how I normally teach it for the first time at GCSE. And then we can kind of sketch it slightly quicker. And you get faster at it the more you sketch them. So what we do is we do a little graph or a little table. And we have some x values. And our y is this time x plus 3. So what you have is you're going to choose some values between, say, minus 10 and 13 for x. So we could have, say, minus 8. I'm going to have minus 2. Let's go for 3 and maybe 5. Doesn't overly matter, but as long as it's going to fit within our axes, we may as well do 10 as well. So you've got a good few there. Officially, we only really need 2 points to work a straight line graph, but it's better sometimes to work out more. And what we need to do is, this is the equation y equals x plus 3. You have minus 8 plus 3, which is minus 5. Minus 2 plus 3 is 1. 3 plus 3, well, that is 6. 5 plus 3, well, that's 8. And 10 plus 3, well, that's 13. So you have x is minus 8, y is minus 5. You can put them across on the thing. When x is minus 2, y is 1, which puts across there. When x is 3, y is 6. So we go along and across. So we have x is 5, y is 8, which puts you here. And then we have 10 and 13. Well, when x is 10, y is 13, that doesn't actually fit on the graph. So then what we'd do is we have a ruler and we'd join up those points. Now, what you should do really, is possibly extend it beyond just our points, like so. So I'm doing this by hand. Obviously, I'm on a computer, so I could have obviously just used a graph drawing tool, but that's not really of any use for you guys when you actually have to plot it yourself. Let's look at drawing another one, but let's go for red this time. So I'm going to have my table line. We have x, we have y equals 2x minus 1. Doesn't really matter which values we choose, but we might as well choose some which fit. So it doesn't really matter which ones you choose. We could have minus 10, minus 4, minus 1, 2, and 5. We'll do for those ones. So what we do is you plug in our values. You have 2 times minus 10, minus 1. Well, 2 times minus 10 is minus 20. Minus another 1 is minus 21. 2 times minus 4, minus 1. Well, 2 times minus 4 is minus 8. Minus another 1 is minus 9. 2 times minus 1, minus another 1. Well, 2 times minus 1 is minus 2. Minus 1 gets you minus 3. Then you have 2 times 2 minus 1. Well, 2 times 2 is 4. Minus 1 is 3. Then we have 2 times 5 minus 1. 2 times 5 is 10. Minus 1 is 9. Let's plot this on. So x is minus 10. Y is minus 21. So that's like down there. Well, we're not even going to bother writing that one. It's on the graph. When x is minus 4, y is minus 9. So minus 4, minus 9 ain't quite on the graph, but should be somewhere down there. When x is minus 1, we're at minus 3. So minus 1, minus 3. Boom. When you get 2, y is 3, so along at 2, up 3. And 5, 9. It's along 5, up to 9. Boom. And there we go. We have a nice straight line. And what about where they meet? Well, this point here, which I'm going to do with a black point here, is at the point 4, 7. And in fact, we have just done a simultaneous equation graphically by just drawing two lines on the same graph. Now, what we had here is you had y equals x plus 3 and y equals 2x minus 1. Now, if we were to solve these linear simultaneous equations, what you could have had is y equals y, or x plus 3 equals 2x minus 1. So we kind of solve for it. So what I'm doing here is just now solving for it algebraically. Well, what I'm going to do is I'm going to put the minus 1 on the other side. So I'm just going to add 1 to both sides, plus 1. So you have x plus 4 equals 2x. And then we take away x, and we take away another x on both sides. So you get 4 equals x, or x equals 4. Same thing, just written the other end. Then we can go, well, y equals x plus 3. So our y equals 4 plus 3, which is 7. So you have x equals 4, y equals 7. If I go back to my graph, you'll see, now I've zoomed in on it, that they are meeting at the point 4, 7, which is what I just calculated with the just calculating them linearly. Let's have a little look at this next one. So here we have plot 3x plus 4y equals 24. Now what we could do is we could rearrange to maybe make y the subject and then start plugging in some values for x to work out y. But another way we can actually make this much easier in plotting is you're going to make x equals 0. So what we're going to do is what is the value of y when x is 0, and then we're going to do the same to work out the value of x when y is 0. So we have 3 times 0 plus 4y equals 24. Well, that basically means 4y equals 24. So we haven't got to worry about the x's at all here. And we have 4y equals 24, so y then equals 6. So we have a point of 0, 6, which we can plot on. So when x is 0, y is 6, so that's up at the top there. And then we can do the same thing. So we're going to make y equals 0. So we have 3x plus 4 lots of 0 equals 24. That means 3x equals 24, and x therefore equals 8. So you have a point down there, and then we basically join them up. What I can then do is I'm going to make that line longer, so although it's like so, and like so. So that is that line going between those 2 points going through the graph as shown. So let's have a look at this next one. Well, when x equals 0, we have 2 times 0 minus y, so we have basically minus y equals 5, and therefore y equals minus 5. So you times by minus 1. So we have x is 0, y is minus 5. So that's down the bottom there. And when y equals 0, you get 2x equals 5, and therefore x equals 5 over 2, or you can write that as 2.5, which is somewhere down the middle. And then what you can do is you can join out those 2 points. Let's extend that line. And where do they intersect? Like so. So where are they going to intersect? Well, they intersect at this point here, which is when we have the point 4, 3. So what we have is that the x equals 4 and y equals 3. and that is it's solved with a graphical method. So let's have a little look at this next one, where we have plot y equals x squared between -5 and 5. And here we are actually going to plot it, not sketch it. I don't think I've ever actually seen this come up in A level, but something similar have come up with GCSE. And we have between -5 and 5, so I'm going to just actually go -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. So we might as well start at 0. So 0 squared, or 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And 5 times 5 is 25. Now let's go through the other way. So -1 times -1, it's 1. -2 times -2 is 4. -3 times -3 is 9. -4 times -4 is 16. And -5 times -5 is 25. Now, what I've got coming up on the screen now is two axes. And the big thing really, the difference between them is the scale. So you could have a normal square, like we've got on the first one on the left, and we could plot these on. So now we've got our set of values. I'm going to have to zoom in on the first scale, because the first scale is a bit hard to actually plot on. And we have 1 times 1 was 1. So probably somewhere down there. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And 5 times 5 is 25. And then 0 times 0 is 0. 1 times 1 is 1. Or -1. -2 times -2 is 4. -3 times -3 is 9. -4 times -4 is 16. And 5 -5 times -5 is 25. So this is have a go at drawing the line, as I'm doing here. And the more you do that, so you'll get. So that is freehand drawn. You do not use a straight line. But that is here where your values on your y are a different scale to the values on your x. Now what I've got here is where I've got a 1-to-1 scale. So again, 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And 5 times 5 is 25. All the way up there. Then it's basically the same on the other side. So you can see how it's slightly different looking-ish in terms of the y value is a bit more steeper. So let's see if I can freehand draw this. So, and then we go down. And we're going to go back up. There we go. Freehand drawn the best I can. Now, obviously, I could have used a graph drawing device or a formula thing. But again, I don't really see the point in me doing that because you haven't got the ability to draw these things without the joy of freehand and graph paper. So have a go at sketching the x squared graph, and then we're going to plot on another graph on. So now we've sketched or drawn the x squared graph, what we're going to do now is we're going to plot y equals x plus 6. So I'm going to do a little table. We've got x and y equals x plus 6. So this is just a straight line. I'm not going to do every single point like last time because last time was quadratic. So I'm going to choose -5, -1, 1, and 5 may as well. So -5 plus 6. So -5 plus 6 is 1. -1 plus 6 is 5. 1 plus 6 is 7. And 5 plus 6 is 11. Then we're going to plot these on. So -5 and 1. So I'm going to zoom in on this graph. It's probably somewhere about there. Then we had, so I have to zoom in and out because it's a bit fiddly. -1 and 5. So that's there. 1 and 7 is somewhere about there. And 5, 11 is somewhere over there. And then we can then join our line up to be something like that. Now let's draw the same thing, but on the other graph. So at -5, we're at 1. Then at -1, we're at 5. Then at 1, we're at 7. And 5, we are at 11. So I'm then going to join those dots up. So let's get that to do that. Voila. And here, this again is a simultaneous equation, but with graphs. So if you had y equals x squared, you've got y equals x squared and y equals x plus 6. What we have is 2 points where they intersect. So it's a bit fiddly to see on this graph, but you would see they kind of cross it certainly at -2 and 3. But it's easier on this graph here, where we have this point here, which is -2, 4, and this point here, which is 3, 9. So they have x equals -2, y equals 4, and x equals 3, y equals 9. So that is the simultaneous equation solved graphically. So I've plotted 2 different graphs on, as you can see, and then where they intersect is where they are solved simultaneously. Why don't you have a go at exercise 3C? You only really need to do the first few, maybe the first 4 drawn out. Might be worth getting some graph paper and have a go. You could try and sketch some of the other ones, or you can always go on something like Wolfram Alpha and ask it to plot it. So if you're not sure exactly what it would look like, then that's also worth doing. And if you're not sure, just try and calculate it. So it's normal simultaneous equations. They don't really get you to plot. I don't think I've ever seen actual plotting of graphs, but I guess they could. Tends to be sketch this or sketch that. That tends to be how it is. So have a go now. The answers are on the screen. You can see in the answers there's only some of them which they've got plots for, sketches for, and the answers they aren't actually accurate. They're more sketches of the graph. So have a go there. And then I hope to see you obviously in the next video, which we're looking at inequalities, which is also those arrows and which way they're pointing.